All right, welcome back to season 2 of Detection at Scale. Today, I'm here with Josh Liburdi, who is a security engineer on the team at Brex. Josh, great to see you. We've met in the past. Really excited to have you on the show and talk about a lot of the amazing things that you're working on right now.
Yeah, thanks so much. Happy to be here and great to see you again. Really excited to do this.
All right, let's jump in. So give us a little bit of a sense of your background, what you do at Brex, and then I have a personal question for you about what motivates you to keep working in security.
Yeah, so I've been at Brex for a few years. I mostly work on what I would call security operations. So detection and response, corporate security, security automation, all of those kind of things is usually what I'm focused on over here. And then I've been in the industry for, I think this is my 11th year. So I spent about half my time as more of a security analyst at really big companies, worked at a couple startups, and then at some point, switched over into security engineering. And that's kind of how I've ended up where I am.
And what motivates you, Josh, to keep working in this field of SecOps?
It's funny. There's a lot of things that kind of motivate me. One is that there's just more work to do, which is kind of like a sad answer. For some people, probably there's just like so much more to do to make things better. And I don't mean necessarily at Brex. I just mean like, the general we, the royal we in that statement. That's the thing that motivates me to like build tools, share tools, open source, things like that. But also it's just really fun to like cause a bad day for a bad guy who's trying to break into your environment. Like that is the thing that I think is really exciting about this work is when you catch a bad guy and you're like, oh, I'm kind of ruining your day. Sorry, bro. That's a great time.
That resonates. I love that. And the answer of there's always more to do, it's spoken like a true engineer. Work's never done.
Even when you've shipped, it's never done.
Of course, never, ever. So it's a good segue into talking about Substation. So folks who have followed your work or followed Brex are probably aware of the project, but it'd be really great to just get the backstory, what it is, and the why of why you all created it at Brex. So take us through that.
So what it is, these days, I call it a security data pipeline toolkit. It deploys in AWS. I think about it as being like a modern version of Logstash or Fluentd, like really great tools from yesteryear that were designed in the cloud era, right? So that's basically what it is at a super high level. The reason why we built it is because when I joined the team at Brex, I had come off from working at larger companies that ran kind of similar projects on tech like Kafka, Logstash, actually. So I had a lot of experience dealing with like log collection at scale. And intuitively, I think anyone who's done this job for a while knows that every security team, at least every SecOps team, they really like live or die by their data and the quality of their data. And I think if you can have really great quality data, like in the first stage of your data collection process, you can accelerate your threat hunting, your IR, your detection, like so many use cases. And so that's kind of why, like personally, I made a bet that, we were going to need something like this soon. Like it was started development 3 years ago. There probably wasn't really a need to have something that advanced 3 years ago. And to be clear, like 3 years ago when it started, it wasn't advanced. It was like a very small scoped kind of thing that evolved over time. But I think like, in my opinion, having worked on big and small security teams, like the problems you deal with are identical almost. The scale is different, but like a small security team still needs good data. They still have to deal with like the reality of running a security program in a business that changes day over day. And having tools that allow them to collect their data, make it highly usable, and not think about managing it or scaling it, I think is really important for whatever size team you're on.
So there's a lot of components to this. Aside from just log collection, there's a whole transformation element, right? And that's how you're really improving the quality of the data. So can you talk a little bit about features and problems you were solving on the transformation side?
I'll give you an example. I think this is a problem that most people know exists, but they probably don't really think very hard about it, or they don't recognize it. And it's that if I collect log data today and I put it in my SIM today, and I go to analyze that data a week from now, so much has changed in the business on the internet over the course of that week that by the time I actually go to look at that data, say on a threat hunt, the analysis I do could be incorrect, could be inaccurate. The geolocation of an IP address I'm looking at could have changed. An IP address that was once on the Tor network might no longer be on the Tor network. The servers associated with the DNS resolution associated with the server might have changed. So this is a problem that I think is very obvious to anyone who just takes a minute to think about it, but that a lot of the analysis that we do is after the data has been ingested, and sometimes it's days or weeks later. And if you don't have a snapshot of all the information about that server, user, system at the time it occurred, the information just decays over time, right? So that's the high level problem that Substation, and I think these other kinds of tools like it should be trying to solve is, let's collect all the metadata and everything we know about this server or user or system, whatever it may be, at a moment in time, and then just commit that to disk, to storage, whatever it might be, so that we can do, useful, good analysis later. So things that we do, they're part of the public repo. They're we have lots of examples in there. IP geolocation is just a table stakes feature for us. Every public IP address observed in any event log gets geolocation data attached to it. Same for reverse IP lookup. We do user attribution in the same way. Every user gets their metadata that's known about them at the company attached to that event data. And I think a lot of analysts and practitioners are used to working through a model where the data lands in the SIM, and then the SIM is doing things to enrich that data at runtime, or maybe it's doing it on a schedule. But even then, I think you're still running the risk of incomplete analysis, inaccurate analysis, but also you're more dependent on your SIM provider, right? Because I've worked at SIM providers and companies that have since bought SIM providers, and their ability to do real-time analysis like this is generally pretty poor. And it's because they have to do it all at once. It's really difficult to search 2 terabytes of data and then analyze it in real time as it's being searched and scanned off disk. But when you do it in the data pipeline, like Substation, it's, scaled out. So there's more opportunity to actually collect that data. We're kind of just approaching it we have a different mindset about how we approach data collection. We actually try to push as much analysis as we can do to the left. We try to never do it in the SIM if possible.
It's pretty interesting. I think the one question I have as a follow-up is, you made a great point that indicators like IP geolocation, things like that change, and we need to be able to go back and get the most fresh version of that data. But if you're streaming it through, take me through a bit how that works. I think I'm missing a key piece of context or something.
For example, in our data pipeline, we have a process that pulls an IP database that has your metadata in it about your IP, geolocation, ASN, that kind of stuff. So when we observe the IP in our data pipeline, we do that enrichment there. That data is just written directly into the event with the IP address, whether or not it existed in the source or not. So when that event is committed to the SIM or the database or whatever data lake you have, the metadata of the geolocation, the reverse IP lookup, et cetera, that is just part of the event. It is not an enrichment that's added later. It is just now all part of the same JSON in our case.
So it's all about the stream time enrichment, cleansing, things like that. Are you doing any other types of transformations on the data? Can you talk a little bit about that? Like the data model and some of the other top level concepts?
Yeah, I think the data model is a pretty big, important piece of it. It's hard to do enrichment without a data model because you're literally converting the format. You're changing the format of the original data. So we do use a common data model. It's one of the popular ones. We use ECS, the Elastic Common Schema. OCSF, I believe, is pretty popular if I got the acronym right. That one's pretty popular now too. I mean, they're all fine. You just pick one that your team likes, basically, kind of going back in the history, I'm pretty sure Substation predates or was started around the same time that OCSF started. So like, it's just, for us, it's just, the thing didn't exist back then. I think when I was picking our data model, I even looked at Cybox, if anyone remembers that. But like, there's like lots of like legacy data models, and honestly, like the whole like story of like the thing that we've built is just like take something that's old and make it a little more modern, which is something that I like to do. Like, why reinvent the wheel? But we've improved it quite a bit. The other thing we do that I think is kind of interesting is like, it is part of data transformation, is the idea that your data can tell you things like you collect lots of data, right? Like you collect lots of data from lots of sources. In some cases, it might be dozens, SaaS applications to identity providers to EDR data. And this is only ever giving you like a snapshot of what it knows. Like EDR can only tell you about like what process executed on a system, but it very rarely actually tells you like who owns that system, like what user is associated with it. In some cases, it might not even tell you the host name that it ran on. It might just give you like an ID. And it definitely can't tell you like, is this process interacting with one of your servers, or is it interacting with a server on the internet? Like, how do you differentiate like in the public IP space, like what is our stuff versus like their stuff? And so we do a lot of that. So we do a lot of data enrichment and transformation that is like information in one data pipeline can help make information like events in another data pipeline better. So, we add host names to all our EDR logs. We add user information to all of our EDR logs. So we know when a process runs on a system, like that person is, in finance or they're in engineering. And that's really useful, I'd say, context to just understand like, is this normal? Because I think that's the goal, right? Like you do all this log cleaning, normalization, transformation, just to help your team like separate normal from, malice and detect the bad guy at the end of the day.
Yeah, that context is really, really important. And I want to talk through the next step of that, which is around detection. So have you seen a big improvement in your ability to write better rules after Substation? And can you talk a little bit about that?
Yeah, I think it helps a lot. I mean, one, I think it really reduces our reliance on the SIM. Not that like that's a good or bad thing. It just means that SIM has to do less. So it can be simpler. And in general, like there's some SIMs that, you might be billed based on how often you query. And so if we can reduce our query time by, 100%, 200% by just doing most of our enrichment in the data pipeline where it's cheap, there's value there. From a pure detection point of view, like the example of, someone in a certain department of the company should almost never run this command. Like, simple example, you should never like execute a Python script that was just placed in your temp folder. If you work in like finance, right? For example, like pick a random department that's not engineering. Like that stuff becomes trivial because our event has the process name in it. It has, in most cases, it has the parent and the grandparent process also in it because we enrich that. It's got the user information in it. It's got the host name in it. Like it takes what would have been like a very complex, like join kind of query or subquery to like introduce like 3 different data streams into one to do a detection into just a simple, like regular expression kind of match detection. And so a lot of what we do is all in service of just make the detection so simple, no one could misunderstand what it's doing. No one would misunderstand like why it exists, because sometimes you see these detections that are, written in like SIM that are like, again, this is not to speak like unkindly of SIM products, but like sometimes you see these queries and they're insane. They're like 20 lines long. They've got 2 joins in them. Like they need a run book just to describe what it's doing. And our goal is just like offload all that to the data pipeline and make the SIM so simple that, our CISO could operate it.
By the way, I always run my Python scripts from /temp. I just feel like it's such an easy to remember directory. So I do that a lot. I'd be setting alerts off left and right. No, it's really interesting. And I agree. I think there's a huge opportunity for good data and like really simplistic enrichment to save a lot of pain downstream all the way to alerts, which we haven't talked about yet. We're just talking about creation of those things. But I guess one of the questions in my mind is like, which operations do you think are always still beneficial to run on search time versus in the stream? Because there are certain things that are very hard to do in stream regardless. So how do you think about the delineation there?
For me, the search time is like research. And I always like try to push the team to like go further. It's like, you're doing this at search time, but could we actually do it in the pipeline in real time? And the answer is like, surprisingly, like usually, yes, we can do it in the pipeline. And kind of going back to like the way Substation is designed to make that as easy as possible. It's basically designed to make it easy to have like a big idea and make it a reality in an hour, that kind of thing. But I would never tell someone like, hey, you should use Substation to do a threat hunt. That would be a terrible idea. Like, you should never use Substation or a data pipeline system to do incident response. Like there's always like different use cases for when you need to do like a deeper investigation. An example of where we are now starting to experiment with pushing things even further left in our like end-to-end system, which is like, source, data pipeline, SIM, analyst is kind of like the flow, is even our, we call them detection signals. So these are like micro detections or like low level detections, like, a person ran a Python script from temp is an example of a signal. We're trying to push those even further left. We've almost never considered them to be an alert. We've almost always considered it to just be data. Like, this is just something that happened in our environment. It's not good or bad. It's just like a fact that this happened, right? And so we're just trying to treat that like more metadata about what is happening in our environment. And we do the same for indicators of compromise as well, where I'm sure and like a lot of people know that like IOCs, they go out of date pretty fast. Their value decays over time. Sometimes they're just wrong, depending on how good or bad your feed is. So we treat it all like data, and then we do a lot of our analysis at runtime. And so we're trying to push all of our signals in IOC matching left into the data pipeline so we can build high fidelity alerts in the SIM. And those then would look more like correlation kind of alert. Like, I observe these signals for this kind of user, and, if I can baseline even the group, right? Like the finance group, like, do they usually do this thing? No, like we have an outlier here. So that might raise an alert or increase a risk score if you have like a risk scoring system. I think like that, like really detailed lower level analysis needs to stay in the SIM. But the data pipe, like if you're doing like string matching, regex matching, all of that stuff can be offloaded to a data pipeline really easily.
Yeah, it saves a ton of time retroactively too.
Hey, Detection at Scale listeners, heading to RSA this year? Join us Wednesday, May 8th at 3 p.m. at Yokai for an in-person interview with Corey Quinn, Chief Cloud Economist at the Duckbill Group. You know Corey as the voice behind Screaming in the Cloud and AWS Morning Brief podcasts, not to mention the mastermind of Last Week in AWS. Come meet us in person at Yokai on May 8th at 3 p.m. Visit panther.com for more details.
And I fully subscribe to what you're saying around signals. I think we've talked about it on the show probably a few times, just this idea of layering, right? Like tagging things, layering things, and then getting higher fidelity aggregate alerts on the back end of that. And that pattern has been emerging quite a bit, especially as things scale up, which is kind of going on to the next question of like, how do we effectively do threat hunting and response at scale when there's just so much data and you can't really rely on naive, like free text searching anymore?
The answer is just don't look at all the data. Just don't this is like, it sounds like a joke, but like, it's so wrong that people think like, oh, the MITRE attack framework exists. I need to fill in the bingo card, right? And have coverage across the entire thing. It's like, no, like the reality is only a few of those things actually matter. And in my opinion, persistence matters, C2 matters, lateral movement matters. Those are the areas where if I was like tasked with giving you just like the bare minimum things you should focus on from a detection point of view and like what you should care about, it's those. Because bad things are about to happen when the attacker gets to that stage. Like very bad things are about to happen. Like who cares that you're being scanned externally, like recon, right? It just doesn't matter. In some cases, like, I mean, I mean, I'm definitely not speaking on behalf of my employer here, but you can even say like, who cares if a phishing email gets in as long as someone didn't open it? Like if we had a preventative control that stopped someone from opening it or disrupted an attack, like, does it matter that the fish landed? So you really have to think about like, and this is tough for a big team because big teams are so siloed usually, but like, if you think about like security operations in the context of the larger whole of the security org, and like, what value am I bringing if I focus on these areas? That's how I try to think about it. And a lot of that just is like, hey, like this data we have is great data for incident response, but not detection is kind of the answer usually. It's like, we're going to save this data for when we know we need it, but for now, we're not going to look at it. I don't know if that really answers the question you asked, but...
No, it resonates a lot. I mean, I fully agree with you with what you're saying on things in MITRE. It's all contextual to what your threat model is and to what your appetite for noise is. You would never have a rule that looks at scanning because it just doesn't matter and it's constantly happening, right? It's like having a rule every time it rains. It's like, okay, it's going to happen all the time.
I will say that I've worked at places where I want to definitely draw a distinction between collecting data and not looking at the data, because anyone who's worked with me knows I love to collect data. And I think that there has been a pushback in the industry against collecting data because so many people don't know the distinction of like, just because you collect it doesn't mean you have to use it 100% of the time. You know, like VPC flow logs love to get trashed on because there's just so many of them and they provide arguably so little value for detection. I would say they're pretty high value if you need to confirm that data was exfiltrated out of a network and you want to know how much data left. Like in that case, they're super high value. So it's not that you shouldn't collect it. I think you need to figure out how to collect it in a reasonable way that's affordable, that is highly usable. Again, going into the data pipeline idea, like we can make that data better and cheaper. It doesn't mean you have to like start detecting every time someone scans SSH on your network, but like, do you never want that data? I don't know if that's true.
I think like everything, you have to have intention with collection. If you just collect star on all the VPC flow logs, it's wasted data a lot of the time. But if you're very intentional about certain accounts, VPCs, port ranges, whatever other type of way you want to slice it, it becomes valuable for IR, like you're saying. Fully agree.
Yeah, I think it's tough because that would require, well, I won't say highly intelligent, but like a high level of interaction across teams to know the answer to that, right? And that's what you miss in big teams usually is like, do I really understand the network of my entire business well enough to tell you, like, yes, we need to be collecting just this 1%. And usually the answer is like, no one really knows that. They just collect it all and then figure it out later. And if they're unlucky, they'll just collect it all and put it in their SIM and make their SIM vendor like very happy when they get the bill. So yeah, it's tough. I think like it's also tough because small teams don't usually have the opportunity or time to think about these problems. Like there's just so much to do on a small security team. And like, again, like I'm a big advocate of like, don't build tools that already exist. Like if you're building something, it needs to be providing value beyond what you can just get off the free market, like open source or pay a vendor to do. And I am biased, but I do think like Substation fills that need. I think there's like vendors popping up in that space now. I don't know how well they will do in the future, but best of luck to them. It is like, I'd say, an unfulfilled need in a lot of security teams, is having like the ability to collect and clean data.
For sure. It's a hard problem. What are you doing in between the pipeline and wherever, you'd call your SIM, whatever that box is? Are you doing anything in the middle around tech like Iceberg or Delta or something similar to that to make the data a little bit more usable across the organization? Or is it purely just fed into the SIM and that's the end of it?
Yeah, for us, it's just fed into the SIM. We have non-security use cases for it. We usually just give them access to the SIM. It's just like very simple, right? But I do think like to some extent, if the security team is maybe more capable of collecting all this data and making it available to other teams, like engineering teams, and they should do that, Iceberg or Snowflake or whatever your data storage system is, like if the data is not so sensitive it can't be shared, then I think there's value in that. We just don't do that. We just don't have the use cases where I work now.
Yeah, that makes sense. Let's talk about response. So you had some interesting talks and things about response. We'd love to just get your thoughts around like what modern response looks like after you've gone through the pipeline, the rules. Now you have an alert. Tell us about your methodologies of handling alerts, treating alerts as code, things like that.
Yeah, so I'd say modern response is highly automated. I think modern response is boring. That should be the goal. Make it boring. And if you've done that, you've done a great job, because like automation is boring. Like it is just like creating like a alert that anyone on the team should be able to analyze. And when they get the alert, it should have all the information they need on it. In theory, it's really hard to achieve. But if you've done that, kudos. And that's kind of like our approach, is just like continuous improvement of how do we make our job easier, right? But not let the bad guys off easy. So we're highly automated. We use like a modern kind of SOAR workflow platform for that. We build a lot of things in it. I think this is like a point I really want to make too, is that like our team is pretty small. We're definitely capable of building our own apps. I mean, we've got Substation, and we've got another app we haven't open sourced that is also quite large. I don't know that we will ever open source it, but we really typically work in like simple apps, like our SOAR platform. Like it's just faster. Like why would I write Python, deploy to Lambda, deploy an API gateway just to do like one interaction for one alert? Like, no, I can do that in 20 minutes in my SOAR. We really just kind of like optimize for efficiency. And that's both from an engineering point of view, but also an operations point of view. And so like, I think like making your work simple and boring is like beauty. Like that's the dream. Like, I don't want to like this job is stressful enough when like things are real and bad things happen. Like you don't want to be dealing with bad alerts and failing automation. And like, no, it's just like, let's just like simplify things, remove the complexity. Like, I think anyone that I work with or have worked with in the past, like they're probably hearing this and they're like, yes, like Josh is very annoying on this point. Like always simplify.
I love it. Make it boring. It's a good lesson to walk away from today. Make certain parts of the job boring, make certain parts of the job easy, and then put your energy when, you actually need to. I think it's just actually good life advice generally.
Yeah, there's so much that we do that to a large extent, the promise of SIM and SOAR is that, I think, is like, we're going to make it's almost a little like more menacing, I think, when you hear it from a marketing person where they're like, we're going to make your team more efficient, which some people like then think like that means you need less people on your team. But that's not usually what it means. I mean, usually what it means is like, no, we're actually going to let the machines do what the machines are good at, so the humans can do what the humans are good at, which is analysis. Like machines are terrible at analysis. Like I don't care what Gen AI, LLM stuff comes out in the next 2 years. Like I've seen the results. They're not all that great right now. Maybe they'll get better, right? I'm hopeful on that. But like, let the people do analysis, let the machines do the data transformation, and the automation of like the incident response. That's really what my thoughts are on that.
You gotta be nice to the AI, Josh. They're gonna be listening to this in 10 years.
I've already, accepted my fate, and I will be the first to go. So it's
Yeah, I mean, I think with Gen AI, the pace of innovation is so fast here. So keeping a pulse on it's very important. But I think a lot of people overlook the fact that the job that we do in security is about understanding how humans interact with other resources. And it's very hard to just say objectively like, oh yeah, that's bad. I mean, you can do it, right? There's a lot of things that are objectively bad. Like you mentioned, one is like, okay, if I run this very known malware in this location, that's just a pattern we've seen over and over and over again. Like that's pretty much bad. But when people are, especially in MITRE ATT&CK, I think is a huge offender of this is to do certain parts of MITRE ATT&CK. They're like, look for unusual X. And it's like, okay, got it.
Yeah.
And I was doing a lot of reading and searching on correlation just because that word is so overloaded in security. And I found so many different definitions and answers. And some of them were like, an example of correlation is looking for a weird version of this. And I'm like, again, like, come on, this is just magic. So I think getting clarity there and actually having a good understanding of when Gen AI can be used for actually finding interesting patterns that humans may not see, I think is a big opportunity. And you need to use it in the right ways and optimize the pipeline, the data. Like that's a crucial part of doing anything with AI is great data. And I think that's what companies like Snowflake and Databricks are optimizing, right? They're like, you need good data to do good AI, which is true. So a lot of the work you're doing on Substation and things like that, and just sort of like pushing this mentality through into SecOps really helps us stay armed in the next wave of tooling that comes out. And as LLMs advance, we'll be able to take more advantage of that. So that's what I'm excited about personally.
Yeah, for sure. I mean, they will undoubtedly advance, right? This has been apparent since the release of ChatGPT. Like this is just the genie's out of the bottle, right? Like this is not going away. So get used to it. I'd say today I would put a human with a spreadsheet up against an LLM and say the human would win in their analysis. Like, you know, if you just gave me like rows in a spreadsheet, I would probably beat the LLM at that analysis for security, like DNR work anyway. But do I think that'll change? Like, absolutely. And yeah, I mean, like, you really can't overstate the value of just having data that, whether you're giving it to a machine, an AI, a person, like clean data. Like one of my favorite like people in this industry, just based purely on like a very kind person, but also just like based purely on like their like thoughts and research is Chris Sanders. And he puts a lot of thought and effort into like the psychology of security analysis. And I don't know that people like really appreciate like how mentally taxing it is to have to look at, you know, 5 different data sources. They've all got different formats, like even an IP address in all 5 are probably in a different field. So it's mentally taxing to just like do the gymnastics of like, okay, this IP address here maps to that IP address over there. And then when I combine them, it becomes this. Like that's like, you know, to reduce the cognitive load, I think is a big reason why we do so much data normalization. Because we really just want, again, like make it boring. Like I don't want to think very hard. I just want to see the data and make a conclusion. I don't want to have to spend 10 minutes trying to understand what the data is telling me. I just want to intuitively have it get me there.
Yeah, and explanations are something that an LLM can be good at if it has the right training set. And there's certainly an opportunity to just overload an LLM with a lot of docs and a lot of like interesting golden image things, because that's always the thing that I found quite magical about working with certain analysts is I'd be like, how did you know that that exact event with these arguments meant this? It's just so magical. So I think we'll get there, and I think we'll see a huge up level in defense. So I'm excited for that. Josh, so last question is 3 pieces of advice that folks can walk away from today through your 11 plus years of knowledge and wisdom. What can you drop?
First, you should ask for help. Like everyone should be asking for help always, basically. Like no one knows everything. No one expects you to know everything. I certainly don't know everything. So just ask someone you trust for help. Like the best advice I can give anyone. You know, that's kind of in line with like, always try to not be the smartest person in the room. You know, you want to be like actively learning. Like there's a very non-technical aspect to this as well, where like maybe this is actually the second point, like soft skills matter, especially in this line of work, most especially if you're on the incident response side more than the detection side, because you're probably going to work with a lot of different folks who don't know you, maybe don't trust you when you first meet them, especially as an incident responder. And you say like, hey, I need you to turn off your service because it's compromised. And they're like, wait, what? You want me to do what? This is going to cost us how much money to turn this off? Like in business dollars? I think it's really valuable to just like a great engineer is not just good at building things. They're also great at communicating intent, getting people to rally behind ideas. I like to play devil's advocate to the annoyance of the people I work with, just to really like understand, like, are we making a great decision with whatever we're doing? So I think that is really important. I don't know. I guess, do I want to be controversial and bring up build versus buy again? Maybe the third point is don't build everything in-house. It's my personal opinion. Building products is really hard. I'd say I've probably done it 1.5 times in my career now. The half time being when I worked on Strelka at Target. I only say that's like a half product because I never really got it there before I left the company. But yeah, like it takes a lot of effort to build a really great project and then sustain it for years. And there's a reason why not everyone runs their own company. And it's probably because of that. The point I want to make about that, though, is that like we strategically buy things so we can focus more effort to build things that don't already exist. Like you could argue Substation exists and things like it exist, but I would say in the same way, no, they don't really exist. But you really have to understand like where are the gaps in our program and like, can we get like 2, 3, 5x value out of building our own thing? And if you can, then maybe you should. And if you can't really do that, then just pay a vendor and move on with your life. It's easier that way.
Awesome. Josh, this was so fun. Loved having you on. I learned a lot by listening to you. I'm very inspired. I think I'm going to go run a mile now because I'm so inspired. But thanks for your time. It was amazing talking with you, and hope everyone enjoyed the episode today with Josh. And I guess before we end, like, how can folks keep up with what you're working on? Can you plug your socials and your Medium and stuff like that?
I'm on LinkedIn, Josh Liburdi on LinkedIn. You'll find me there. I'm on Medium. I think that you'd find me on there through just searching my name as well. Or I go by JSHLBRD, basically my name without the vowels. Not on Twitter. I've retired officially, and I'll be at B-Sides, San Francisco, if you're there. So if you're there, say hi. That'd be great.
Awesome, Josh. Thank you so much. And we'll catch you all next time.